Hi guys, let's work on the stem and leaf plot. Let's learn this, eh? Cool, let's get started. Alright, let's change it to nice red so we can see what changes I'm making. So stem and leaf plot. You have a stem, you have a leaf. So if you think about a plant, obviously the stem is the kind of like the rooted bit in the middle, and then the leaves shoot off it. So what I want to go over is what does these numbers say? Well, we have a key here, so this is going to be a big hint. But, so 0, 1. Well, that would read as 0, 1, which is 1 years old. So what you could say is that these numbers here in the stem, and only in this case, the values of the numbers can change. It just happens to be that these are 10s now, but that these are 10s. So we have, when we look at this, we have 0 10s. And how many 1s do we have? Well, we have 1 1s. And this comes from the series of numbers where it's like 1s, 10s, 100s. You know what I mean? Millions, whatever. It comes from that series of numbers. So we have 0 10s. And if we look at, let's say, this one, well, we have 2. 8, which is going to equal 28 years old. And why is that? Well, we have 2 10s plus 8 1s. Simple addition, right? So hopefully you guys get a good understanding for that. Understand that this could be different. So let's say our key was 6, 3 is equal to 6.3 years old. Well, what would we have there? Let's look at this example. So we'll go with this one. Well, 4, 4. Actually, I'll change the color so that way we represent a new key. So we'll go with this. So say that this is our new key color, okay? So we'll go with what? 4 and 4. Well, that was 6.3 years. So this one here is going to be equal to 4.4 years. So how did we get this? Well, in this case, these represent 1s, and these represent, I guess, tenths, or 1/10 of 1. So we have 4 times 1s, and we have 4 tenths. So understand that the stem isn't always going to be equal to 10s, and the leaf isn't always going to be equal to 1s. Now, here's the interesting thing. Why do we have a stem and leaf plot? Well, if you think about it, there is a graph that it's very similar to, and that is a histogram. I know it may not seem like it, but the similarity comes from the fact that we have, I'll do another color here as well. We'll go with a nice little teal. Well, you can think of this as a bin. This here is equal to this. Because the values are between and equal, so it is between or equal to 0 and 1. Oh, god damn it, John. Okay, between equals 0 to 1. So this value here, so you can think of this as a bin. As such, this is also a bin. Oh, seriously, guys? But you can think of this bin as 1 to 2, and so on and so forth. Now, what is the advantage of this information here versus this information? So what is the advantage of our stem and leaf plot versus our bins here? Well, the answer shouldn't surprise you that much. What we can do is see the information within a bin. So before, with a histogram, which was, let's say, this, right? Let's have the histogram like this. We had these bins, 0 to 1, 1 to 2. Oh, that's too small, but you get what I mean. But we didn't know the values within them. But now we do. We know that this bin, 0 to 1, contains a 1, a 1, a 2, a 2, a 3, a 4, 4, a 4, a 5, a 4, a 5, and an 8. There's one more piece of information that I want you to take away from this as well. and that is frequency. Once again, frequency comes up. We can look at this information and see the frequency. So how often, what is the proportion of ones in the data? Well, we see that we need to look at this row here. So we have a 1 here and a 1 here. So that's 2. And how many are in the data set overall? Well, there's a lot. So we're just going to say n. So 2 of all the values that we look at, are equal to 1, and we can see the frequency of that. But you can also see the frequency of 4, or you can see the frequency of 38, which is 0. It doesn't exist. See, there should be an 8 there if there was one.